Hello, this is Mrs. Lewis again with today's lesson on relative dating methods. We use relative dating to place an event in order by comparing it to other events. In geology, we want to find out the age of a rock layer. If you looked at this picture right here, it would probably be fairly easy for you to say which one of these girls is the youngest and which one is the oldest. However, if you looked at this group of lovely ladies here, you might find that a little bit more difficult to put them in order by their ages. In geology, relative dating is placing rock layers in their proper sequence of formation. We don't know exactly how long ago these rocks formed, but we are able to say which layer is the oldest and which layer is the youngest. There are some rules that we use for dating rocks. Rule number 1 says, in sedimentary rock, the oldest layers of rock are on the bottom. They formed first, and the youngest layers are on top. So if we look at this formation here in the Grand Canyon, this bottom group here, this is the oldest, and this group is next oldest. This one on the top is the very youngest. Another rule that we can use is that layers of sedimentary rock are deposited in a horizontal position. They were deposited while this part of the land was underneath water, and as they were deposited, here we can see these horizontal lines. So each layer of sediment here was deposited in a horizontal position. They call that original horizontality. Using these rules, we can figure out that if a rock layer is folded or inclined, like this here, this is folded, it must have been disturbed after it was laid down, because it was laid down horizontally and then something happened to uplift it or fold it. Rule number 3, when a fault cuts through rocks, that's what happened after the rocks were laid down. So for instance, you see these cracks here, and this layer of rock should match up with this one and this one and this one, but there was a fault. So there was movement along one of these cracks here. And when that happened, that could be a movement this way, or in this case, a horizontal movement, and that puts them out of alignment. So we know that the fault must have come after the rocks were laid down. Another thing that we know is when magma intrudes into some rocks, like here we have what's called an intrusion, and here we have a quartz intrusion that was intruded into the rock. And we know that this intrusion is younger than the rocks that it affects. So therefore there was some magma here, and this is going to have crystallized in this rock layer, so it came later. This is called cross-cutting. Rule number 4, inclusions are something that we have to consider. An inclusion is a piece of one rock that's contained in another. So this would be an inclusion in this rock, or these would be inclusions here. And when we have an inclusion, the inclusion, this rock, is actually older than the rock that contains the inclusion. This is younger, and then this rock is the older rock. Rule number 5, unconformities. An unconformity occurs when the deposition of a sedimentary rock stops and the surface is exposed and eroded, and then some deposition occurs again. So here you would have this rock probably laid down under the water, and then it got exposed and there was some erosion, made an irregular structure all along here, and then later it was underneath the water and more sedimentary rocks were laid down. That's an unconformity. There are two types of unconformities. One's called a disconformity, like we have right here along this line is a disconformity. So the sedimentary rock, these layers of rock here, were laid down horizontally underneath the water, and then the rock was uplifted so that it's out of the water, and we had some erosion, and that erosion ate away at the rocks. It ate more away on this side than on this side, and then after the erosion, the water returned again, and we set down some more layers of sedimentary rock. And then here on the top, we see some erosion occurring again. We don't call it a disconformity unless we had some more sedimentary rocks on top. Another type of unconformity is called an angular conformity. That's a little bit more complicated. So in this case, the rocks were laid down in a horizontal way underneath the water, and then the rock layers were lifted up, the water evaporated, and so they're exposed to erosion. But before that happened, something happened to tilt the rock layers. And then after they tilted, then the erosion occurred over the tilted layers here. And then after that, the water came back and they laid down some more horizontal layers. So this is an example of what we call an angular unconformity, because the rock was laid down, but then before the erosion, the rock was tilted. And then after the erosion, another layers of sedimentary rocks were laid down on top. We can use fossils to help us date rock layers also. We know that certain kinds of fossils were laid down at a certain time in history. Those are called index fossils. For instance, these trilobites here and here were laid down and existed at the same time, and so they were found at the time that this rock layer was laid down. So we know that even if something's been moved, that this rock layer here is deposited at the same age as this rock layer, and so we can use that information when we date the rock layers. And looking at the rock layers and putting them in order is kind of like solving a mystery. For instance, if we looked at this pattern of tracks and footprints, we could figure out who was at the crime scene first. There are some important clues here. First of all, the nephew in this crime scene has a seeing eye dog. Secondly, the cook rides a motorcycle to work. The butler walks to work, and the girlfriend drives a Jeep. We can look at this pattern, and we should be able to figure out by how they're laid down who got to the crime scene first. Would we know then who murdered Uncle Charlie? No, but we'd know who got to the crime scene first. So when we analyze rock layers, we're going to know which rock is the oldest and which rock is the youngest.